Now let's get at slope. Now, slope is the type of concept that you've learned 20 different ways from Sunday, and there's a good reason for it. It's because slope is really, really important for physics and for later science classes and later math classes. It's a really big deal because slope is your rate of change, and we're going to talk more about that in another section or so. So let's remind ourselves what slope is. Very, again, extremely important number. So important, in fact, that they put it on road signs. This is an actual road sign, I swear. Right? So slope is a measure of the steepness of an object. So steepness, let's remind you of that, is your vertical distance over your horizontal distance. So for example, when they say this 25% thing, right, which they do, by the way, that's from Hawaii, very steep road, and you're breaking your rental contract to do it. So when they say 25%, what they really mean is 25, oopsie, over 100, right? Per cent. Per means division, and then cent means 100, century, right? It's 100 cents in the dollar. So that means that you're going 25 vertical feet for every 100 horizontal feet, which I have to tell you is quite steep in a car. You actually break your rental agreements. I would not let my husband drive down this road because it breaks your rental contract if you're on the big island of Hawaii, to drive down into this valley because 25% is so steep, right? Um, Very few places allow, well, rental cars and trucks and stuff like that to go down roads that are that steep. I mean, I'm from Michigan, so I feel like it's steep when I'm driving through like Tennessee on I-75 and I get 4% grade and I'm already freaked out, right? Because Michigan, for all intents and purposes, is a pretty flat state. All right, all things considered. All right, so it's 25%. So it means you're dropping 25 feet for every 104 feet horizontally. And you think, oh, what's the big deal? Well, it's a really big deal if you're a truck driver. I mean, that's why they put signs up. I mean, if you're driving on I-75, they have those wipeout ramps so that in case your truck loses control, it's got a place to go, which, by the way, freaked me out when I first drove through there. I was a teenager and I had to drive to Kentucky, and I was not pleased when I realized what those things were for. So, again, I'm a wimp. All right, so let's say you're going to go skiing near Traverse City, Michigan at the Boyne Mountain Ski Resort. So a skier stands at the top of the hill. I remember doing this when I was skiing. And you look and you've got two slopes, right? So on the left, it says that it's 9% grade. They have a little sign. And they usually have diamonds involved. And then, the little black diamond, little red diamond, whatever. And then the other side states a 4% grade. Which one is steeper? Because it kind of matters, right? So I personally could ski at a 4% grade. I'm not good on a 9% grade. So which one's steeper? The slope with 9% grade is steeper, right? The larger grade, i.e. slope number, the steeper the slope will, or the hill will be. So that's what I wanted you to notice. Slope is a numerical, i.e. a number, measure of steepness. That's what I want you to get out of this. When you find slope, you are finding a number that measures steepness. The bigger the number is, the more steep it is, right? Bigger number, more steep. Right? Smaller number equals less steep, right? Shallow would be the word, right? Like handicap ramps. When I made my grandmother a handicap ramp, it was supposed to be to code. So for every one, and in Michigan, the code is 1 to 12. So if you're going to do a handicap ramp, just in case you're ramp, well, I guess what I'm getting at here a little bit is that slope seems like this kind of nebulous idea until you work in building construction. So in building construction, you realize very quickly that slope's a big deal because there are grades for roofs. Like roofs have to be certain grades or should be certain grades. Handicap ramps should be certain grades. Handicap ramps are quite shallow. You can imagine you don't want a really steep handicap ramp because if the person's handicapped, they might not be able to keep control of their wheelchair and they might tumble out. Or if they're with walkers, that's even worse because then they are struggling to make it up the hill. steepness of your, if you ever have to re-roof your house, you realize steepness matters. Steepness matters a lot for how secure you feel on that roof. If it's a flat roof, you don't care, but if it's really steep roof, that's very hard to do. That's when you think about hiring professionals, right? All right, so what is slope? You've learned about slope 20 different ways from Sunday, I am sure. So what is it? Let me pause this and I'll be right back with the answer. Poof, it's like magic. Okay, so slope is that vertical change over that horizontal change. Now that's rise over run. You've probably learned that in various places, and that means it's y2 minus y1 over x2 minus x1. Right, now let me go get a graph and I'll be right back. All right, there we go. I made a graph. Okay, so let's take a look at this for a second. Oops, I think I'm gonna need bigger. Okay. So I want you to see, and I'm just going to swap this out. So it's the same grid. It's just looks a little different. Okay, so you've got 2 points on there, and you could have picked any 2 points on there. It doesn't really matter which ones. And you can see, hopefully, that you have a vertical distance between these 2 points, and you have a horizontal distance between the 2 points, right? So you have this vertical distance right here, and then the horizontal distance here. Let me make that vertical distance really bold so you can see it. Okay, so that's vertical. Oops, I made the arrow go away. And then let's see here. Oops, let's draw another one. There's the horizontal distance. All right, so if you know the ratio of the two, then you know the steepness. I mean, it's very much like building a staircase. I mean, think of this like a stair steps, right? So if you have, if you're building a staircase, the blue parts are called the runners, right? That's literally what they're called, like rise over run. That's where that comes from, right? So the blue parts are called the runners, and the orange part are called the risers, right? Actually, you also get treads in there, but you bear with me, right? So you can imagine that that ratio is kind of important. Like my mom's old house was an old farmhouse, and this was so steep. She had really tiny blue lines and really big orange lines. It was a dangerous staircase, right? Because back in the day, they built really steep staircases. They didn't have code, in the 1800s in their farmhouses, right? And so it was just whatever you built, right? And they've done studies of what, slope people are comfortable with and that kind of thing. And you can see that this is consistent across the line. There's a relationship here that's steady, that I could keep copying and pasting these blue lines and it's going to keep working every time. Right? Now, why does it work? Well, it works because slope is something that's consistent. That's what makes a line, is that slope is the same all the way through, right? That it's consistently happening over and over and over and over. It doesn't change over time. If it changed over time, that would make it a curve. So linear goes up, over and up, over and up, over and up every time. Right? Now the question is, what does it go over and up by? That's what the the slope is. Slope is a number that measures that. It's your vertical over your horizontal. Like in our case, it would be, slope would be, I'll put it up here. Slope would be, now let's think, the vertical is the orange bits, right? So when you look at the orange part, you're going up 2. So you start at we always read the graphs from left to right. So you always start at the left end and work your way up. So you'd go up 2 over 3, right? And by the way, it doesn't matter if you put the lines on the left or the right. So you could say I go up 2, right 3, up 2, right 3, right 3, up 2, right 3, right? It doesn't really make any difference whether you put them on the top or if you put them on the bottom. It's still going to work, right? You can have them consistently be top or bottom, right side of the graph or left side. So you could say I go up 2, right 3, up 2, right 3, up 2, right 3. And it would have worked the same way with the other way. Before I had it right 3, up 2, right 3, up 2, and that works too. Right? So it doesn't matter which way you do this, as long as you've got that relationship. That's what your slope is a measure of. Oops. Let's save that there. All right, so there's our slope in our example. In our example below. Right? Of course, it'll be different every time. Okay, so if that's what slope is a number that measures steepness, right? And you have a formula for it and everything, right? Then we're going to have to find the slope for the equation of a line that would contain the following points. So let's do it, shall we? Okay, so slope is m. M is equal to, let me make this a little bit bigger so you can see it. M is equal to rise over 1, which is y2 minus y1, oopsie, over x2 minus x1. Okay, now that is going to be, now which one's y2 and which one's y1? And my answer to you is it doesn't matter. So I'm going to make the first point is the x1, y1, and the second point is the x2, y2. That's the way most students do it. So I'll say negative 1 is my y2 minus 3, because 3 is my y1. And then my x2 is 2, so 2, take away my x1, excuse me, is negative 4. Now I put extra parentheses in there just to kind of make sure it's clear that I'm subtracting a negative. You don't have to do it, but it's kind of ugly, yucky if you don't. Here, let me show you. So if you don't do it, then it's just like minus a minus 4. Okay, so it's a little bit better mathematically to put parentheses around it to make sure you denote that it's subtraction of a negative. Okay, so now what does that become? Hold on. All right, so my numerator is negative 4, and my denominator is, because negative 1 minus 3 is negative 4, 2 minus a minus 4, that's 2 plus 4, which is 6. And then we would always, like the good algebra students we are, we would always reduce our fraction down to its lowest terms. There we go. And by the way, in case you're wondering, can the calculator reduce the fractions? Oh, and another thing, how do you get out of this screen? You're thinking like, I don't want to look at the graph anymore, I want to do this. So you go second, quit, right? If you had negative 4, not minus, clear, divided by 6, and you want to reduce it to lowest terms, you can press math and number 1 right there, convert fraction. See that little triangle fraction thing? So you pick number 1. So it's saying, hey, I'm going to take negative 4 over 6, I'm going to turn it into, that's what that little triangle means, a fraction. You press enter, and there it is, negative 2/3. It might not show it in this little form. It might be negative 2 over /3, but it'll be the same idea. All right, so now let's do it again, but with these points. All right. So let's see here. Oops, come here. Okay, so my points are different, so I've got to do this part all over again. So let's see, it's y2, which in this case is 3, take away y1, which is also 3, 2 take away minus 4. Now, this is a little bit interesting. 3 take away 3 is 0, so it's 0 over 6, but 0 over anything is 0. Remember from pre-algebra that if 0 is in the numerator, that's 0. Let's make a note to ourselves, right? If the slope is 6 over 0, that is undefined, not no slope. I know some teachers teach as no slope. That is not the way we are going to work with it. It is undefined. That's our definition. So make a big note of that for yourself. Speaking of which, okay, are we good? Okay. I suppose I should say if the slope equals 6 over 0, that's undefined. All right, now what about increasing and decreasing lines? Hold on, let me fill those in. Poof, I filled it in like magic. So an increasing line has positive slope, which looks like this one. A decreasing line has negative slope, like this one over here. And then I will pick up right here next time. See you then.